हरि करना।
Okay, now let's look into the second technique from probability sampling, that is systematic sampling. So, systematic sampling is often used instead of random sampling because it it's also called as nth name selection technique. So systematic sampling is also called as nth name selection technique. After the required sample size has been calculated, every nth record every nth record is selected from a list of population elements. As long as the list does not contain any hidden order, so this sampling method is as good as the random sampling method. So its only advantage over the random sampling technique is simplicity and possibly cost effective cost effectiveness. So systematic sampling is a probability sampling technique in which a sample is selected by taking every kth individual from a population. Okay, let's take this. This is our study population from a city, and now using systematic sampling, how can we sample the elements? How do we do that? So now I have to decide the kth individual I want to sample every time. Okay, so now let's take, for example, if I decided that kth individual I want to sample from a population every time, then the first individual is selected randomly from the first k individuals. That's very important aspect. The first one would be random. The first one would be random. And after that, the first individual is selected randomly from the first k individuals in the population. And then every kth individual after that is selected until the desired sample size is reached. For example, so first we will label the respective elements in our population with the numbers 1, 2, 3, 4, and 10, 11, 12, 13, 14, 15, and so on. So now, to use the systematic sampling, the first individual is selected randomly from the first k individuals. But before that, let me decide the kth element. So here I have decided fourth element is our sampling element. Okay, so that's our sampling unit. So fourth element. So then what I did, my k value is 4. So out of this first 4, I will take up randomly any one of it. Okay, randomly, it's okay. First one should be the random, then after that once. So this is my first element that I have randomly taken, this guy. And after that, once the first individual is selected randomly from the first k individuals in the population, then every kth individual after that is selected until the desired sample is reached. I want to take 3, so the first one is selected, and after that fourth element, 4, 5, 6, 7, 8, this girl has came here. Then after the fourth element, 9, 10, 11, 12, this guy has came here. And after that we do not have, we need to go for the 16th. So this is what we call it as a systematic sampling. The most important point to be remembered is the first element, the first kth element should be the randomly selected from the first k elements. Okay, then after that you can select the kth individual after that is selected until the desired sample is reached. Okay, let's take one example to understand this better. So it's systematic sampling. So suppose same example, we have a population of 1000 individuals, 1000 individuals, and we want to select a sample of 100 individuals from this 100 individuals from using using sampling interval of 10, sampling interval of 10, that's the K. And for that we need to go for the systematic sampling. Let's do that. So let me take the same data frame, the whichever we have used before. So let's create a data frame with 1000 individuals, and then same columns. We know about this data frame before. So now, so for systematic sampling, we have to select the first, we have to decide the sampling interval first. Let's determine the sampling interval. So sampling interval K is equal to 10. Then select the first individual randomly. That's what our first activity, as I have told you before. So for that, start is equal to np.random.randint 0 to k. That's it. So 0 to k. From this you have to select 1. So start. This is what we got, 8. So if you want to see data, so this is our data. Out of that, out of 10, the first k, out of 10, out of total 10, the first element was selected from the initial 10 rows. That was selected randomly. That was 8th row. That was 8th row. Okay. So 8th row is the first individual. Now select the systematic sample. Now you can select the systematic sample. Okay. So sample is equal to data dot ilog, and start is the first one, and after that you go for the kth interval. Every time you go for the kth interval, and then do it till end, and show me, just give me 100. That's it. So let's let's print it in the same way as we did it before. Okay, so this is my study population. We'll keep it same, and then this here I'll change this to systematic SS. Let me put SS, systematic sample. Yeah, and execute, and here is your, okay, SS is not defined. Oh, got it. Yep. Okay, let me change this first. Systematic sampling. Yeah. So this is our study population, and this is our systematic sampling, and you got the 100 rows. And if you see, the first row, 4th row was selected randomly. Then 14, 4 plus 10, 14, 14 plus 24, 14 plus 10, 24, 24 plus 10, 34, 34 plus 10, 44, 44 test plus 10, 54, and it goes on. That's it. That is our systematic sampling. Again, I'm repeating, uh, the first element should be selected randomly in first 4 if our k value is 10. Okay, the first element should be selected randomly from the 4 elements. Okay, from the 4 elements. Then after that, you have to you have to increment it with 4 4 4. So this is what is called systematic sampling. So by using systematic sampling, we can ensure that sample is representative of the population while reducing the time and cost of the sampling compared to the simple random sampling. However, it's important to ensure that there is no periodic pattern in the population that may bias the sample selection.